Hello and welcome to this video lecture on Chapter 12. Today we'll be talking about information systems development. And one of the reasons why you probably need to know about this is because you may have to actually have a system developed for you or a system modified, or be in the middle between the technical side of the development and the person who's actually going to use whatever that's being developed or modified. So you need to understand that process and how it can be managed, and that's what we're talking about today. So as you read the opening vignette of the chapter, you see something like the following. We think we can open the doors to an entirely new market. So that gives you an example of the kind of discussions that small businesses are having all the time. It also means that this is how new systems get developed or how systems get modified. Managers are around talking about what else they can do differently, some new ideas they might have, and all of a sudden you need a system or some kind of technology to support that new idea. And so as you get ready to start that new idea, you're thinking about, what's exactly involved? What sort of things am I going to need to know? And so this starts that process of thinking about your costs, what kind of different options exist. It also provides you a way of thinking about, okay, I need a prototype of some type so that I can see if this is actually going to work. And then you get other people involved to see how well they think this plan is going to be, and that if they're using this system, they're more likely to use that system once it's fully implemented. So if you go to work for a small company, then you might find some of the things that were on this slide here. That is, that you might be involved in a small startup company. This could be a very exciting time. Everything's moving quickly. You got to get things done, long days of work in order to get everything working together. You'll have limited amounts of funds in order to get those systems designed and get your work done. You might not be able to hire people, so you got to think of different ways to be more efficient. You'll be coming up with new ways to have prototypes to see if something will actually work or not. And so again, you'll be going through this development process. And so again, that's what we're here talking about in this video lecture. So there are several questions that to be asked and answered in this chapter. And so one of the things is, what is system development? And so system development looks at all those components of a computer information system. So we're looking at the hardware, the software, the data, procedures, and people. And so when we develop a system, we've got to think about, okay, what type of procedures are going to be involved? What is it that we're trying to do? What kind of people are going to be involved? What kind of data is going to be generated? Typically that's going to be for your reports or data that needs to be passed on to other systems that will use the data in their system needs. Then once we know this, we then have to decide what kind of hardware, what kind of software is going to be needed in order to develop this entire system. So once we understand this, then we have these requirements that also go along with this in terms of we need to establish what our goals are. Goals can be not only what we're developing, but is there a cost that's involved? Is there a time limit that's involved? All those things are part of this goal setting. And so people who have good project management skills do very well in developing systems. And so a manager in this area would have very good project management skills, even maybe certification in that area. So again, we're looking at all of these different components of the system. You've got to be knowledgeable about everything. If you want to be a business analyst, you're knowledgeable about the current procedures and maybe the new procedures that you want to develop in terms of this is how you're going to be more efficient or more effective, and so this is how you're going to use your system in order to do that. So an example might be, let's say you've got a restaurant and you're currently using some kind of turnkey system where you take your orders, you put your receipts in, you kind of keep track of all the foods that you're different serving, and that system generates reports for you. But now you want to add some way to manage your bar receipts. And so the question then becomes, okay, how are you going to do that? Who's going to provide the information? What people are going to be involved? How is that going to be handled? Do you get orders when they first get placed, or does somebody bring back an order and then that gets put into the system? And so how are you going to keep track of all of that? How are you going to keep track of your inventory? How are you going to keep track of your sales, so on? What kind of hardware and software are you going to use? Are you going to develop the system from scratch, or are you going to go out and buy what I would call a turnkey system? That means it's already been developed. You more or less buy the hardware, software, it's got it loaded on there, and now you're going to have to follow the procedures that this system was built around. Well, a lot of times that doesn't work for people, and they need a customized system so that they can mimic the procedures that they want. And it may be that they get the strategic advantage because of those procedures and not just doing procedures that everybody else in the industry is doing. This next slide deals with some terminology, and that is business processes, information systems, and applications. And that is, people tend to confuse these or think these relate to the same concepts, when in fact they don't. The relationship of business processes to information systems is many to many. You might see it abbreviated like this, N:(M). This is similar to the same concept that we have with relational databases. So that means that there can be many business processes that are related to many different information systems, and many different information systems can have many different business processes. So something that may be difficult to understand then is a process doesn't necessarily have to relate to any information system, but an information system relates to at least one business process. So an information system is a business process that you've automated somehow, or you've captured using that computer system. Now, you may still be doing something manually that hasn't been put into an information system yet, and so that process isn't related to anything. All right. Then this third item here, every information system has at least one application because every information system has a software component. So we're using some form of application to help us mimic that business process. So the next question that we want to answer is, why is system development difficult and risky? And so as managers, you need to understand this, because this could have an impact on your career in a major way, especially early on. If you take over a project where you're doing some kind of system development and it fails just massively and you cost the company a lot of money, chances are you're not going to have a good career or a long career with that company. So some things to understand is that a lot of times people will come up with these ideas, they sound good, and they start doing them, and then the company doesn't have enough resources to finish the project, or the project doesn't turn out the way it thought it would do. So a lot of projects never finish. Another thing that they've noticed with projects is that people do a poor job of estimating how much it will cost to do a information systems project. So they're usually, or many times, 200 to 300% over budget. Once they're done, if they go back and look at their initial goals, they don't meet the goals. And so there's a high risk of failure. And I would say, even with doing a application type system, that is, you buy a system that's already been developed, if you have to make modifications to it, you may still have problems of finishing the project. It may still be over budget and so on. You know, classic example that I've heard of is with Fruit of the Loom. Fruit of the Loom has tried to implement CIS several times and has not done a good job. I believe they're trying to implement it again right now, and they're spending millions of dollars trying to do this. And so again, these projects can be very risky if you don't do certain things to try and avoid that risk or minimize it. So one of the problems with a project is that it's hard to come up with the exact requirements. Right? So you see this little graphic here. What exactly do you want the system to do? And this is where a systems analyst and a business analyst should be able to go in and determine that and have a very good plan, a very good set of requirements before they ever start developing anything. Another thing that happens during projects is something called scope creep. Scope creep is where the requirements or the scope of the project changes as the project moves along. So you have actual users, managers who will be in charge of the system. They see what the system can currently do and they keep adding to what they want the system to do. And so those requirements keep adding up, and that's the reason why projects go over budget and why sometimes they never finish. And so that relates to this process in terms of involving scheduling and budgeting. Right? Another thing that can occur, and that hasn't occurred as much lately, other than, we've got technology where we might have been developing a system and now we're going to the cloud. So that would be an example of this changing technology where we're midway through a development of a system and all of a sudden new technology comes out. It looks like it's going to be more efficient, more effective. So now we want to switch to this new technology, and that means we have to redevelop the system and change things on our hardware and software side and how we manage it. And again, that adds to, the over budget and the scheduling and the scope creep and so on. And so lastly here, another challenge to system development is diseconomies of scale. And that's where we're not, because we add more people to a project, it doesn't necessarily mean we're going to be able to finish the project earlier. And so you run into those problems in terms of being over budget. So some ways to address these problems, especially with change in requirements. One thing you can do is incorporate some of those changes along the way, or you can make those changes in the maintenance phase. So if you were a business analyst, you would say, okay, I'll take these changes into consideration, and if we can do them under budget now, we will. If not, we'll put them down to do later so they come up in the maintenance phase. If I'm a consultant, I love changes because then when a change comes, I can just charge more. And so you got to be careful if you're hiring somebody outside and you start making a bunch of changes, then they're going to start charging you every time you make one of those changes. And they'll be glad to do it, but that's how come you get over budget again. So make sure you know exactly what you want before you get started with your project. Some questions to ask yourself in terms of scheduling and budgeting. You need to think about or ask whoever you're working with, how long is it going to take to build, how long to create a data model. The data model is similar to what you see in the relational data models that we've used in those relationships in our Access database. So somebody has to lay out all the entities. Those entities typically become tables, and then how are they related and so on. Then they have to build those database applications, and there's some testing that has to be done. This is the big step here that a lot of people will leave out in order to save money, but it really hurts you in the long run. That is to develop and document those procedures. If they're not writing up the reports on how to use the system, how the procedure should go, and so on, then when employees turn over and they're not there with that history in their mind, then you've lost that history, that information, and now nobody's got it written down anywhere. You also need to think about training for your employees, whoever's going to use the system, and then how much is that going to cost, your labor hours, labor costs, so on. And so lastly, the bottom line is, what's the rate of return on this investment? So if you cannot estimate how much the system's going to cost, then how are you going to be able to do any kind of financial analysis to see if it generates, appropriate amount of rate of return? Otherwise, you'd be better off spending your money investing it or doing some other type of system. And so that's how systems are picked, if you will. I've mentioned the problems with changing technology. Maybe that causes you to stop the project. Maybe you finish according to your existing plan using old technology. But then the question becomes, why would you build an out-of-date system? You're already using old technology, and your competitors might be going to something new and get a strategic advantage ahead of you. But the problem then becomes, can you afford to keep changing that project and going with the latest technology every time? And so a lot of times, that's why you see when you go to work and leave a university campus, those companies might be using software that are 2 or 3 generations old from what you were exposed to in the university setting. The university setting is going to use the latest and greatest usually, whereas a company, they're going to go with something that they know that works. They're not going to spend a lot of resources changing things if it's going to have an impact on their system. So a lot of times you'll see that they'll keep using the old system because it works with other systems, and if they brought in a new system, they'd have to do a lot of modifications on that old system, on the new system, in order to get it to work with all the other systems that it needs to. So that's something else you need to understand about how does this system going to work with the other systems that you already have in your company. And so we mentioned the diseconomies of scale. Again, you can look at Brooks' law, which more or less says just because you add more people to a project doesn't necessarily allow you to finish the project that much sooner. What you have when you add more people to a project is there's more relations that have to be managed. The new people have to be trained, so you're losing productivity then. And so just adding more resources doesn't necessarily finish that project, and it's still going to be late. So far we've kind of painted a bad picture about system development, but it doesn't have to be. And so there's been development, project management in this area for a long time. Probably one of the best things that you can do is follow a system development life cycle. You'll see that as abbreviated as SDLC. You don't need to memorize this, but it gives you a common set of steps that you should go through. And so when you're dealing with somebody who's developing a system or modifying a system, they should be using this approach so that you know where they're at in that system development life cycle, how far along they are, if they're doing things correctly and getting things done in a reasonable amount of time. And so I'm going to pause right there with this part, and when we come back, we will start with question 3, which deals with the 5 phases of the system development life cycle.